Cursor Composer is a tool that engineers can use to automate thousands of hours of work. However, I would have to pay $20 a month to access this tool. Instead, I built my own version of Cursor Composer, which is much worse and had to spend hundreds of hours learning the domain, but now I only have to spend $4 a month. I'm going to show you how you can use this tool yourself or even build it yourself and customize it to your needs. I'm going to show you every boring technical detail of how the prompting works, how it connects to your file system, and the whole tech stack involved. So Cursor charges about $20 a month for about 500 requests to expensive LLM APIs. However, you can see from Anthropic's pricing, they charge about $3 per million input tokens and $15 per million output tokens. And if we imagine we have 1,000 input tokens and 500 output tokens, as we might have for AI code completion, that comes out to about a cent per request. That would be about $5 for 500 requests. So Cursor's clearly charging quite a bit above what you should expect. Cursor Composer is quite simple. It grabs the contents of your files in your file system, it chucks them into Claude's API, it does a bit of prompting to get out some nice edits, and then it applies the edits to your file. I'm also going to show off a series of prompting tricks that I've used to get it working that a lot of these other big tools such as Ada or Cursor Composer use under the hood. To build our AI, I'm going to use a command line tool called Coev, which connects the AI to your file system. It allows reading files, writing files, and listing files, which is pretty much everything you need to build a cursor equivalent product. You start the command line and then you click the link. It will link you to a dashboard, which will allow you to start writing code that will be the logic behind our program. Our AI program will use the file system in three ways. First, we'll list the file system so we can pick which files should be used as context for the AI to think. Then we'll get all of the files that are relevant as context to feed into the LLM so the LLM knows what to edit. And then we're going to write back to those files at the end based on what the LLM outputted. So you can see here, I've written the logic for listing files, which we're going to use. Then you can see I'm getting all the files here one by one. And then finally, at the end of the function, I'm going to write to all of those files based on some diffs that the LLM produces. The core of our AI is going to be a call to the Anthropic API, where we generate a list of diffs to apply to the files. A diff is composed of starting text and ending text. We'll search the file for the starting text and replace it with the ending text. That's the core part, and we're going to use the Anthropic tool calling API to achieve it. The tool calling API is where we can specify a JSON schema structure that the Anthropic API will try to match. This allows us to say that we want a list of diffs, and each diff should have a name, a description, starting text, and ending text. Adding the description is very important because it allows the Anthropic AI to do chain of thought, which is a technique to make the AI think more about each diff it creates. We also specify quite clearly for the AI what starting text responsibility is and what the ending text responsibility is. This means that when we make the API call, we'll get a list of diffs that will hopefully match exactly what we need. The final step to all of this is that we need to write back the diffs that the AI has generated onto the files. So to do that, we simply search within each file for the starting text, replace it with the ending text, and then using the Coev CLI, we call the write method of our SDK, which will update the file. Now I'm going to generate a website to show you that it actually works even with this incredibly minimal amount of code. So I've been incredibly irritated lately with the terrible surf, and I want the government to get involved and start subsidizing wave pools. So I'm going to ask it to generate a nice website that I can use to lobby my local government to subsidize wave pools. You can see from this, it's generated a nice website with various arguments, similar to the sort of output you'll get out of Cursor or V0 or any of these other platforms, but we built the entire thing ourselves, and we're only paying for the price of the Claude API, which is way cheaper than all of these services. If you want to use this template quickly yourself, you can go to coevai.com and you can look at templates and just grab the code for that template. That allows you to get started really quickly. You don't have to copy paste code from this tutorial or anything like that, but hopefully this tutorial shows you how you can undercut Cursor and get good results and get complete control and really understand how your own AI coding works.